Hello, folks. We are back. We spent our first day of this unit discussing the nervous system and the structure of the neuron. We spent yesterday discussing the action potential and what allows the kind of chemical reaction type stuff that allows for the firing of a neural impulse. And then today we're going to talk about the role of neurotransmitters and identify 7 different neurotransmitters and their functions and what happens if we have too much of them or too little of them in our body. So let's get on to it. So like I said, neurotransmitters are really important in crossing the synapse and allowing that message or impulse to move on to the next neuron and continue that domino effect of firing and sending that message. So I said there are crossing guards that help us do that, and they also act as the keys in the key lock mechanism to open up the dendrites on the receiving neuron to send that message through. But we're going to see there's so much more, and that they're also responsible for kind of governing our behavior. Just like parts of the brain are really important, different parts are important in determining how we behave. So are neurotransmitters. Each type of neurotransmitter has a different function. It serves in helping us in our behavior and day-to-day life. So we're going to get on to it in looking at all the different types of neurotransmitters, or at least the 7 that we need to know for this class, and what they do for us. So again, yesterday we talked broadly that there's kind of 2 overarching categories of neurotransmitters. There's the excitatory ones that make a neuron more likely to fire. So they're kind of your green light go ahead and saying, yeah, keep sending this message. So when it is the key lock mechanism, it's the key that opens up the lock to that receiving dendrite and says, yeah, keep sending this message on through the next neuron. But if it's inhibitory, it is the key and it opens up and it says, hey, let's slow this message down and kind of stop it. We don't need to send it anymore. So kind of the stoplight in that scenario. So now we're going to look at the 7 main neurotransmitters that we need to know for this class. And we're going to look at the function of them and what happens if we have too much or too little. So this is kind of, again, your overarching chart, but I'm going to go more in depth into each one and give you some memory cues as well. So our first guy is acetylcholine. Acetylcholine has to do with muscle contraction, so allowing for us to move, again, whether it's small, fine motor like typing, or big like shooting a basketball like my former student Elise here. She's always going to remain in this PowerPoint now. But it's also tied in with memory and learning. And you're going to see here that as I go through the excess and deficiency of each neurotransmitter, you'll see that these almost help us make sense of the definition and function of what they do. So acetylcholine, if you have too much of it, you might have severe muscle spasms. And this makes sense because if it's tied with muscle contraction and you have too much, it's almost going to cause you to be too much in movement that you're spazzing. Oh, my cat is meowing over here. If you have a deficiency or too little, this could contribute to Alzheimer's, actually. And this makes sense because if acetylcholine helps in memory function, if we have too little of that, that kind of makes sense that maybe Alzheimer's could be connected to that. So memory cues to remember the function of acetylcholine, I said, are muscle action, AA, acetylcholine, muscle action, and then acetylcholine, AA, acetylcholine, Alzheimer's, right? So just remembering that those are associated with each other. Next one, I think, is a fun one that we usually remember pretty well, is dopamine. So, right, if you say something's dope, it's awesome, it's probably a good thing that's giving us happiness and pleasure. So dopamine is our pleasure center. It is our pleasure reward neurotransmitter. So those are kind of the mains when we think of. And this is why you see dopamine is often connected into a lot of addictive drugs, because it gives us that high and that feeling of pleasure, reward, and satisfaction. Also, feelings of love and lust and all that jazz are also highly tied in with dopamine because it's giving us that pleasure feeling. So that's why if you're going through a breakup, Even if it's for the best, it's pretty tough because we miss those kind of feelings of pleasure, reward, dopamine feelings that we get. Also tied in with things though, like voluntary movement, posture, learning, cognition, and attention. So lots of different stuff. Now let's get into the excess and deficiency. So if we have too much dopamine in excess, this could actually contribute to schizophrenia. This is just one that we should memorize. AP likes to ask about this sometimes. So memorizing that too much or excess dopamine contributes to schizophrenia. And then if we have too little or a deficiency, this contributes to Parkinson's. And if you know anything about Parkinson's, again, it's kind of that involuntary movement and tremors. So again, this makes sense that a deficiency of dopamine, too little, if it's tied in with voluntary movement, would associate with Parkinson's disorder. All right, next one. Another one that I think we're familiar with because of things like TikTok. I remember last year, at least around the time that I made these slides, there was that trend going on. It was like things that give you serotonin. Like, ooh, they're going to boost my serotonin, right? So here, we know serotonin, main thing, it's tied in with mood. So it's kind of our mood booster neurotransmitter. Also tied in with appetite, sleep, and impulse control. So looking at excess deficiency, if we have too little, it really makes sense that depression might be a result of this. And there's a really strong link between low serotonin, and depression. And that's why we see when we talk about clinical psych in Unit 8 that selective serotonin reuptake inhibitors, fancy name for a drug that you use to treat depression, right? Serotonin is in the name, that we are trying to actually increase and boost our serotonin levels to alleviate some of your depression symptoms. And again, making sense because depression is tied in with low mood, but also you see lack of appetite, sleep issues, all that, right? These are all things tied in with depression. On the contrast, we got an excess if you have too much of serotonin. This is not something we talk about correlation versus causation. This is something that they found associations between so looking at people who already are diagnosed as having autism, they find that you are more likely to have higher serotonin levels if you're diagnosed with autism. But this is something that needs more research. Again, this is very preliminary things. Like we don't need to know this for this class, but just kind of research that's out there, and they're trying to look in to see just correlation or causation between this. Memory cue here for serotonin. Like I said, you can just remember the TikTok trend of like, oh, that gives me serotonin, right? It's boosting my mood. But also kind of a little acronym type thing or that vibe. We've got serotonin, SS, sleep, and then serotonin, SS, serotonin, sad, right? If you don't have enough, you're sad. Okay, then we've got norepinephrine, a fun one to say. This is your fight or flight neurotransmitter. So when we talked about the other day, we have our autonomic nervous system. You've got the sympathetic and the parasympathetic divisions. When the sympathetic, your gas pedal, fight or flight one is activated, you're going to see that norepinephrine is one of the things that gets released as a result of that autonomic nervous system, sympathetic nervous system being activated. So in here we see norepinephrine is connected to arousal and attention. Arousal meaning that physiological arousal of, hey, I'm going to start running, so I'm going to increase my heart rate, increase my breathing, yada, yada. Attention. So if you think of pupils dilating, right, like this is evolutionary. We've got to pay attention and like fixate now in that fight or flight mode. So going back here to deficiency or excess, if we have a deficiency, this is also connected to depression, which again makes sense because if you're seeing that norepinephrine gives you that arousal, that energy, you know that depression is kind of the opposite of that, right? You're very lethargic and sad. So you might have a deficiency if you have depression. That can make sense. An excess can contribute to anxiety. If you think about being anxious, those physiological arousal symptoms of, breathing, heart rate increase, those are very similar to like anxiety and a panic attack. Going back into evolutionary speaking, Anxiety was a good thing. It's something that helps protect us and gives us that fight or flight response. But now, anxiety is something that's kind of um, malproductive and is not, these symptoms aren't actually helping us run away from anything, right? It's just kind of making our life difficult. So, anxiety is very much tied in with a lot of norepinephrine, and that it's kind of like we have that fight or flight response, but it never got turned off. We never really went into the parasympathetic mode. We're just kind of in that constant activation of the sympathetic. So we have too much norepinephrine. We're going to have to tone that down. Memory cue to remember that it's tied in with this whole fight or flight response is run epinephrine, right? Fight or flight, you're going to run away and flee from whatever's going on. Fun one, GABA. GABA is our primary inhibitory neurotransmitter. And like I said, inhibitory is the stoplight of those two broad categories. It's the one that's saying, okay, let's slow down this message and kind of put it to a stop. So GABA is tied in with anxiety reduction, relaxation, regulating our sleep-wake cycles, and chilling us out. So it's our chill out, calm down neurotransmitter. My memory cue that I just came up with that works for me, maybe it doesn't work for you. I said, yo, GABA, GABA, chill. You can just remember that it's chill. And then if you break it down, you could say GABA, you could say it stands for get a break ahead, right? Kind of breaking down, chilling. If you have deficiency or not enough, you might have anxiety, seizures, tremors, insomnia, right? Because if it's helping us fall asleep, right, the opposite of that, not having enough, would result in insomnia. If it's helping us chill out, if we don't have enough, again, we might have anxiety. On the contrast, if we have too much, we might have sleep disorders in that, you're sleeping too much because you have too much GABA. Okay, 2 more. So we've got glutamate. Glutamate has to do with learning and memory. And in the contrast to GABA, it's our primary excitatory neurotransmitter. So telling the next neuron, the receiving neuron, to continue on firing that message. And remember we talked about long-term potentiation when we did our little sheep demo. And we said that the faster or the more times we did that firing of the message down that neural pathway that you guys created, the more times we did it, the faster we got each time. And the stronger our connection got and those pathways got. So again, long-term potentiation is the idea that the more time you fire a neuron down the same pathway, the stronger that pathway gets and the faster it goes. And that's kind of the basis of like learning, right? Because you're doing this, it's getting faster and better every time you do it and go through it. So glutamate, right? It all makes sense that this is tied in with learning and memory. Don't really need to know deficiency, but too much. Just knowing there's not really, don't really have a reason for this, but it's connected to epileptic seizures. Memory cue, I think of glutamate. I think glutamate glues memories into your brain, right? It's tied in with learning memory, glues the memories in there. Final one, we've got endorphins. You can think of, there's a good video that connects to this in, Elle Woods in Legally Blonde. She talks about it. You can watch it. But endorphins is your pain inhibitor neurotransmitter. And this is one that if you're like on the track team, cross country, whatever, if you've ever experienced a runner's high, endorphins are the ones that are released in response to pain or exercise. So when you're like running so much that you actually kind of the pain's gone and you're like in this state of like just doing it in the zone, you get in that runner's high. That's because endorphins were released. So endorphins help inhibit or kind of stop or ease those feelings of pain. So kind of your ease out, we're going to calm, and not so much GABA, but in that way that like, okay, we're going to ease your pain and calm down. So deficiency of endorphins would be making sense. Your body would experience pain if you don't have enough endorphins going on. But in excess is a problem too, because you might have an artificial high where it's not truly like this isn't what you're feeling, it's just you're hyped up on endorphins, and then you don't experience pain. And actually, pain's a pretty important sensation to experience, thinking kind of in an evolutionary adaptive way of like pain helps keep us safe. If we experience pain because we put our hand on a hot stove without realizing and it hurts and it burns, we're going to remove it, right? So it helps keep us safe. If you couldn't feel that, you would just burn your hand off. So it's an important sensation. So that's what we got here. Right, you can go back to my little overview chart to review the main ideas here. All right, have a good day.